China has the highest number of skyscrapers in the world, with over 3,500 buildings exceeding 150 meters in height. But its top 10 are truly insane. Despite a ban on Megatall construction, the skylines of Beijing and Shanghai are growing massively in scale. From the tallest observation deck in the world to skyscrapers challenging the conventional wisdom of supertall engineering, these are some of China's tallest creations. Don't miss out as we bring you the story of the tallest skyscrapers in China. We begin with a Shanghai landmark and a financial icon, soaring up to a height of 632 meters into the sky. The workers called it the Dragon, as the building rose floor by floor above Shanghai's Lujiazui financial district. Its twisted shape looked like a dragon spiraling into the sky. By the time they finished in 2015, they had built something that would dominate China's skyline for years to come. It is the third tallest building in the world, surpassed only by the Burj Khalifa in Dubai and the Merdeka 118 in Malaysia. But here's the interesting part. Shanghai Tower's highest usable floor sits at 587 meters, which actually beats the Burj Khalifa's top floor at 584 meters. In practical terms, this makes it the tallest building where people can actually work and live. Construction began in November 2008, contracted by Shanghai Construction Group. The project cost $2.4 billion, which sounds massive until you compare it to similar buildings in New York. One World Trade Center cost nearly $4 billion for roughly the same height. Chinese construction costs run about half of what American developers pay, partly because labor costs in China average around $3.36 per hour compared to over $17 in New York. The design came from American architectural firm Gensler. They created something that had never been attempted at this scale before, a building that twists 120 degrees as it rises. The shape isn't just for show. That twist reduces wind load on the building by 24%. In practical terms, this meant engineers could use 25% less structural steel than a conventional straight-sided tower of the same height. The savings added up to $58 million in materials alone. The Shanghai Tower is actually 9 separate cylindrical buildings stacked on top of each other. Each cylinder contains 12 to 15 floors, and together they form distinct zones with their own atriums, gardens, cafes, and retail spaces. The building's double-layered glass facade wraps around all 9 zones, with the space between the inner and outer glass layers acting as a climate buffer. This double-skin design serves a specific purpose. In winter, the airspace between the glass layers warms up cold outside air before it enters the building. In summer, heat from inside dissipates in the buffer zone before it can stress the air conditioning. The result, the building uses 21% less energy than a comparable conventional tower. Wind turbines built into the facade and near the top generate 350,000 kilowatt-hours of supplementary electricity per year, about 10% of the tower's needs. The construction process itself was a masterpiece of coordination. Workers used a repetitive slip-forming process to build the core floor by floor. By April 2011, steel reinforcement had reached the 18th floor while the concrete core stood at the 15th floor. The pace accelerated through 2012 and 2013. By the end of 2012, the tower had reached the 91st floor and stood approximately 425 meters tall. The moment everyone had been waiting for came on April 11, 2013, when the tower passed 500 meters and surpassed both of its neighboring supertalls, the Jinmao Tower and the Shanghai World Financial Center. On August 3, 2013, construction crews laid the final structural beam at the top, officially topping out China's tallest building. At the ceremony, Gensler co-founder Art Gensler declared, "Shanghai Tower represents a new way of defining and creating cities." The elevator system required its own technological breakthrough. Mitsubishi Electric designed elevators that travel at 20.5 meters per second, that's 74 kilometers per hour, faster than the speed limit on most city streets. These are the fastest elevators in the world. They can carry passengers from ground level to the 118th floor in just 55 seconds. 3 of these ultra-high-speed elevators serve the observation deck, supplemented by 3 firefighter elevators that increase throughput during peak hours. Shanghai Tower's observation deck is the highest in the world. Located on the 121st floor at 561 meters, it opened in 2020 under the name Top of Shanghai. This beat the previous record holder, the observation deck on the Burj Khalifa at 555 meters. Visitors standing on this deck can see the entire sprawl of Shanghai laid out beneath them, the winding Huangpu River, the colonial architecture of the Bund, and the forest of towers in Lujiazui. But the tower's success story isn't simple. For several years after completion, large sections of the upper floors remained empty. The double-skin design that makes the building so energy efficient also reduces usable floor space by about 50% compared to a conventional building. The triangular floor plate, while beautiful and aerodynamically optimal, creates irregular office spaces that some tenants found difficult to use. Financial losses mounted as premium floors sat vacant month after month. Critics called the Shanghai Tower a white elephant, a monument to ambition that didn't make economic sense. Marshall Strabala, chief architect at Gensler, pushed back hard against these claims. I would say that the person who said that doesn't know what they're talking about. By 2021, occupancy began climbing as the J Hotel opened and boutique office spaces in the upper floors found tenants. The building's unique amenities, the observation deck, the art space on floors 125 to 126, the Duoyun Books bookstore with free entry and observation decks, started drawing visitors in numbers that justified the investment. The Shanghai Tower also serves as a symbol of China's environmental commitments. The building earned praise as the greenest super high-rise building on Earth. The skyscraper is part of the city's super high-rise precinct on the Huangpu River opposite downtown Shanghai. Its neighbors include the 421-meter-high Jinmao Tower and the 492-meter-high Shanghai World Financial Center by Kohn Peterson Fox. However, none of those buildings come close to the next entry on our list. In September 2015, construction workers in Tianjin topped out a skyscraper that would have become China's tallest building. At 597 meters and 128 floors, Golden Finance 117 beat Shanghai Tower to completion by several months. Then, everything stopped. The concrete stood. The steel frame reached its full height. But in December 2015, workers packed up and left. The building has stood empty ever since, making it the world's tallest unoccupied building according to Guinness World Records. But how did that happen? Golden Properties, the Hong Kong-based developer, started construction in 2008 with big ambitions. The company planned Golden Finance 117 as the centerpiece of an entire district called Golden Metropolitan. The vision included luxury residences, entertainment venues, 2 international polo fields, retail spaces, and green areas spread across almost 2 square kilometers of land in Tianjin's new business district. The tower itself was designed to look like a walking stick topped with a diamond. The upper floors would house a 5-star hotel. The middle sections contained office space. A diamond-shaped atrium at the top included a swimming pool and observation deck. The design came from P&T Group with structural engineering by Arup, the London firm famous for solving impossible engineering problems. And the engineering was truly challenging. The tower stands at a height-to-width ratio of 9.5 to 1, which exceeds China's standard seismic codes. To make it safe, engineers designed a system using megacolumns and massive trusses. These megacolumns are essentially enormous steel and concrete pillars that extend the full height of the building, bracing it against typhoon winds and earthquakes. The construction moved fast initially. Work began in August 2008, but just 4 months later, the global financial crisis hit. Golden Properties halted work in January 2010, worried about cooling property markets in China and major investments struggling in Europe and the United States. The market recovered by 2011. Golden decided to push forward, expecting to finish the tower and begin sales just as property prices reached their next peak. Construction resumed and picked up speed. By July 2014, the tower surpassed 440 meters. By September 2015, it reached its full structural height of 597 meters. Then came June 2015. The Chinese stock market crashed. Golden Properties, which had borrowed heavily to finance the project, ran into severe financial difficulties. By December 2015, money ran out. China State Construction Engineering Corporation, the contractor, removed all workers from the site. The building stood complete on the outside, but hollow on the inside. No windows, no elevators, no electrical systems, no interior walls. The cost of what was built came to approximately $820 million just for the tower, with total development costs including the surrounding mall reaching $1.2 billion. That money sat frozen in an unfinished shell that couldn't generate any revenue. During the years that followed, Golden Properties tried to revive the project. Brief restarts happened in 2016 and 2018, but each time work stopped again after just months. The building became a symbol of China's property bubble. In 2020, partly because of high-profile failures like Golden Finance 117, the Chinese government banned construction of new buildings over 500 meters tall. Urban explorers made the abandoned tower famous in a different way. In 2015, 2 Russian and Chinese climbers scaled the tower and its construction crane. In 2016, Russian couple Ivan Birkis and Angela Nicolau climbed to the top and took photos that went viral on YouTube and Instagram. The empty tower became a magnet for daredevils seeking the ultimate roof-topping location. Meanwhile, the building's records slipped away. When it topped out in 2015, Golden Finance 117 was the 5th tallest building in the world. The twisting Shanghai Tower and Ping An Finance Center in Shenzhen surpassed it while it sat empty. Today, if it ever opens, it will only be China's 3rd tallest and the world's 6th tallest. In April 2025, news broke that construction would resume. Tianjin's municipal government held meetings with China CITIC Group, China State Construction Engineering Corporation, and China Cinda to discuss revitalizing the project. A new construction permit was issued with a completion target of 2027. The $78 million permit doesn't list Golden Properties anymore, suggesting the building will likely get a new name. The new financing details remain undisclosed, but experts believe the Chinese government is backing the restart with investment and debt restructuring. Why restart now after nearly 10 years? Professor Chao Shitong from Duke University School of Law explains it's about signaling confidence. China's property market has struggled. Office vacancy rates are high, but the government wants to stabilize the sector. By having these projects revived and completed, the government at least hopes it can increase people's confidence, Chao told reporters. The question is whether anyone will actually use the space. Shenzhen already has more office space than tenants. Tianjin, a second-tier city, has even less demand. During the decade, Golden Finance 117 sat empty. Tianjin built the Tianjin CTF Finance Center, a 530-meter tower that's now the city's operational supertall. That building already struggles with occupancy. Still, if completed in 2027, Golden Finance 117 will finally take its place in China's skyline. The walking stick design with its diamond crown will stand as a monument to both ambition and the risks of over-leveraged development. At 597 meters, it's tall enough to be impressive. The real question is whether those 128 floors will ever be full. Shenzhen grew from a fishing village of 300,000 people in 1980 to a megacity of over 12 million by 2017. The city needed a symbol of that transformation. Ping An Insurance Company, one of China's largest financial firms, decided to build it. The Ping An International Financial Center stands 599 meters tall with 115 floors. It's the tallest building in Shenzhen, the 2nd tallest in China, and the 5th tallest in the world. The tower opened in 2017 after 8 years of construction that pushed engineering to its limits. Design work began in 2008. American architectural firm Kohn Pedersen Fox created the concept while Thornton Tomasetti handled structural engineering. Both firms had experience with supertalls. KPF designed Shanghai World Financial Center, and Thornton Tomasetti worked on Shanghai Tower and Taipei 101. The foundation stone was laid in August 2009. Construction started that November on a challenging site. The building sits in Futian District's Central Business District, right next to Shenzhen Metro Line 1. Engineers had to dig deep foundations without displacing the subway tunnel by more than 10 millimeters, about the thickness of a smartphone. They solved this with an innovative cross-lot bracing system using two large-diameter rings. The first ring allowed construction of the tower's concrete core. The second ring provided access for removing 520,000 cubic meters of earth, enough to fill 200 Olympic swimming pools. The technique worked. The subway tunnel never shifted beyond acceptable limits. The tower's shape looks like a taut cable stretched between sky and ground. 8 composite super columns extrude beyond the building envelope, creating a distinctive ribbed appearance. At the top, the facades taper to form a pyramid. This isn't just aesthetic. The streamlined design reduces wind loads by 35 to 40%, critical for a city that faces regular typhoons. Shenzhen ranks among the world's cities most at risk for typhoon damage. Engineers designed a tube-in-tube structural system with the concrete core as the inner tube and the super columns forming the outer tube. 5 outriggers and 7 belt trusses connect the two tubes. Additional exterior diagonal bracing adds stability. To monitor all this, 428 sensors throughout the building form a structural health monitoring system. The sensors track stress, movement, wind loads, and temperature changes in real time. If anything shifts outside safe parameters, engineers can respond immediately. The facade uses 1,700 tons of stainless steel, the largest stainless steel facade in the world when completed. The specific grade is 316L, chosen for corrosion resistance. Shenzhen's coastal location means salty air that can rust normal steel within years. The 316L stainless steel will keep its appearance unchanged for decades. Construction hit a major crisis in March 2013. Workers suspected the concrete contained unprocessed sea sand, which can corrode steel reinforcement and make buildings unsafe. Authorities halted work immediately. Testing teams checked the concrete core multiple times. The tests eventually confirmed the concrete met specifications. Construction resumed in late March, but the incident caused delays and damaged confidence. Despite this setback, work proceeded quickly. By July 2014, the tower reached 443 meters and surpassed KK 100 to become Shenzhen's tallest building. One floor was added roughly every 4 days. The concrete core topped out at 555 meters on December 29, 2014. The full structure topped out in April 2015 at 599 meters. Originally, plans called for adding a 60-meter antenna that would have brought total height to 659 meters, making it taller than Shanghai Tower. In February 2015, the decision was made to cancel the antenna due to concerns it might obstruct flight paths near Shenzhen's airport. The building cost approximately $700 million to construct, remarkably economical. For comparison, the much shorter KK 100 cost more, and Shanghai Tower cost $2.4 billion. Part of the savings came from China's lower labor costs and efficient construction methods, but the design also optimized materials. The wind-reducing shape meant less structural steel was needed. The tower contains 33 double-deck elevators, traveling at speeds up to 10 meters per second. These were Shenzhen's first double-deck elevators. Each elevator car has 2 levels, effectively doubling passenger capacity. Installation required a team of specialized welders who set over 60,000 studs using a technique called stud welding, the first time this method was used for elevator installation in China. The contract specified that elevator vibrations couldn't exceed 10 milli-G, an extremely tight tolerance. With travel heights over 200 meters, achieving this required perfect installation. As one installer put it, 30% of ride quality comes from the product, 70% comes from installation. The top of the building houses an observation deck called Free Sky on floors 116 to 118. When it opened, the deck at 562 meters broke the world record for highest observation deck, beating the Burj Khalifa's deck at 555 meters. The deck offers 360-degree views and features interactive displays about Shenzhen's youth culture. Floors 109 through 112 serve as headquarters for Ping An Insurance Company, a Hyatt hotel signed on as anchor tenant in September 2013, occupying 20 floors below the headquarters levels. The lower floors contain office space, with the bottom levels dedicated to retail and conference facilities. The building connects directly to Shenzhen Metro Line 1 at Shopping Park Station. A large podium includes 5 floors of retail shops that terrace away from the tower, creating an amphitheater-like public space. The design pulls people into the building and creates pedestrian connections to neighboring properties. Ping An Finance Center stands so tall, it's visible from Hong Kong on clear days. People in Lantau Island, Shatton, and other parts of Hong Kong can see the tower rising across the border, dominating Shenzhen's skyline. At 599 meters and completed before China's 500-meter ban took effect, Ping An Finance Center represents one of the last opportunities to build this tall in China. The tower transformed Shenzhen's Fujian district into a world-class financial center. It provided Ping An Insurance with a headquarters befitting their status as one of the world's largest investment companies. And it created an icon visible from Hong Kong that announced Shenzhen's arrival as a global city. For a place that was farmland 4 decades ago, that's quite a statement. Guangzhou needed an icon. The city sits on the Pearl River Delta with 11.5 million people, but its skyline lacked a defining structure. In 2009, developer New World Development, a subsidiary of Chow Tai Fook Enterprises, held a competition to design a supertall that would change that. American firm Kohn Pedersen Fox won. They designed a 530-meter tower with 111 floors that would become known as the East Tower. The building opened in October 2016 and immediately became Guangzhou's tallest, China's 3rd tallest, and the world's 8th tallest. The tower sits in Zhujiang New Town, Guangzhou's central business district, on a 27,000 square meter lot along Zhujiang East Road. It's part of the Guangzhou Twin Towers. Across the central axis stands the 439-meter Guangzhou International Finance Center, known as the West Tower. Both towers have similar heights and functions, creating a balanced pair that frames the district's skyline. Groundbreaking happened on September 29, 2009, just 6 months after the design competition ended. China State Construction Engineering served as contractor. The tower topped out in July 2014. By the end of 2015, the exterior cladding was complete. The entire project took 7 years from design to opening. What makes this building stand out is its facade. The tower is wrapped in glazed terracotta, making it the world's tallest terracotta-clad building. The terracotta mullions create a lighter appearance than traditional glass and metal towers. Local environmental codes restrict how reflective glass can be, so standard solutions wouldn't work. Metal mullions could have achieved brightness, but architect Forth Bagley deliberately chose terracotta to inject into the architecture an indigenous craft that was specific to Guangzhou as a city. The material has practical advantages too. Terracotta is self-cleaning, which matters in a coastal city where salt air and pollution coat buildings quickly. It's corrosion-resistant, so it won't degrade over decades. And it's easily produced and shipped within China, reducing both costs and environmental impact from transportation. The shape changes as the tower rises. Different uses require different floor sizes, so the building tapers to accommodate those demands. The lower floors contain offices with larger floor plates. As you go higher, the building narrows for serviced apartments. The top floors house a luxury hotel with smaller footprints. This functional stacking creates the tower's distinctive silhouette, not just aesthetic choice, but practical necessity. Inside, the building mixes uses in a way that creates a vertical city. The basement and podium contain a massive shopping mall called K11 Art Mall, owned by K11, another Chow Tai Fook subsidiary. The mall occupies the entire 8th-floor podium plus 2 basement levels, covering 70,000 square meters. About the size of 10 football fields. It features a 4DX cinema with 8 screens. Offices fill floors 7 through 43. These Grade A office spaces total about 209,000 square meters, with flexible floor plates that support various business configurations. The offices include conference centers and modern amenities designed for multinational corporations. Serviced apartments occupy floors 49 through 70. These luxury residential units provide high-end living with hotel-style services, targeting executives and wealthy residents who want a home in the clouds. The Rosewood Hotel opened in spring 2019, taking over the top 16 floors plus podium spaces. A 5-star property with 365 rooms, the hotel puts guests at heights few other hotels can match. The top floors include amenities like rooftop pools and premium restaurants with views across the Pearl River Delta. Transportation connections run deep. Underground, the building links directly to public transit through basement-level connections. Pedestrian bridges at ground level connect to adjacent buildings, creating a network of climate-controlled walkways that let people move between structures without stepping outside. An underground parking facility holds 1,705 cars. The elevators are record setters. Hitachi designed 95 elevators that travel at speeds up to 72 kilometers per hour, some of the world's fastest. At that speed, passengers can go from ground level to the 111th floor in less than a minute. The building handles up to 30,000 people daily, so these high-speed elevators aren't luxury, they're a necessity. The construction moved at incredible pace. Guangzhou CTF Finance Center holds unofficial recognition as the fastest assembled supertall in history. Workers completed one floor roughly every 3 days during peak construction. This speed came from careful planning, prefabrication of components, and coordination between multiple teams working simultaneously on different levels. The structural system uses a composite design, combining a reinforced concrete core with steel elements. The core provides vertical load-bearing capacity and lateral stability. Steel framing around the perimeter allows for the irregular floor plates that change size as you ascend. The combination creates a rigid structure that can handle typhoons, earthquakes, and the settling that occurs in all tall buildings. Maintenance of a 530-meter tower requires specialized equipment. Rostec, a Finnish company, provided nearly 300 meters of concealed monorail track for building maintenance units. 2 self-powered platforms and a 10-meter motorized gantry allow workers to access every part of the exterior facade for cleaning and repairs. Some 42 meters of track remain visible, but most is hidden to preserve the building's clean aesthetic. The tower sits in a district that also includes the 604-meter Canton Tower, a telecommunications and observation tower that dominates the city's skyline. Together, the Canton Tower and the Guangzhou Twin Towers create a cluster of supertalls that announce Guangzhou's status as a major economic center. At 530 meters, the Guangzhou CTF Finance Center represents sophisticated urban planning. Not just a tall building, but a complete vertical neighborhood with shopping, working, living, and hospitality all stacked efficiently in one structure. The terracotta facade links modern engineering to traditional Chinese craftsmanship, creating something that's both futuristic and rooted in local culture. In the Tianjin Economic Technological Development Area, about 150 kilometers from Beijing, engineers built a tower that looks like it's melting. The Tianjin CTF Finance Center, completed in 2019 with a distinctive curved glass skin that gently undulates as it rises 530 meters into the sky. At exactly the same height as its sister building in Guangzhou, 530 meters, this tower takes a completely different approach to design and construction. Both are owned by Chow Tai Fook Enterprises, but the similarities end there. Skidmore, Owings, and Merrill designed the Tianjin Tower in collaboration with Ronald Liu and partners. The brief called for a mixed-use building in Binhai New Area, a district positioned to become Tianjin's new financial center. The city has 13 million people, China's 5th largest metropolis, and a major port on the Bohai Sea. Groundbreaking happened on November 20th, 2009. Full construction began on January 3rd, 2013. The project took 6 years of active construction, finally reaching substantial completion on September 22, 2019. The tower has 97 floors, making it the tallest building in the world with fewer than 100 floors. The building's shape comes from practical requirements. The tapering form, created by reducing floor plate sizes as you ascend, minimizes surface area exposed to wind, sun, and moisture. This matters in Tianjin, where winter temperatures drop below freezing and summer typhoons batter the coast. 8 sloping megacolumns curve around the building's exterior, following a line that connects the centers and corners of all 4 elevations. These megacolumns aren't decorative. They're integral to both the gravity and lateral systems, meaning they carry the building's weight while also resisting sideways forces from wind and earthquakes. Tianjin sits in a high seismic zone. The megacolumns increase stiffness in the building's perimeter frame, pulling a larger portion of seismic forces away from the core. Chinese building codes require this for structures in earthquake-prone regions. The curving columns also create natural stiffness at the building's base, where lateral loads concentrate most heavily. The undulating curves serve another purpose: confusing the wind. When wind hits a rectangular building at consistent speed, it creates a phenomenon called vortex shedding. The wind separates on either side of the building and forms swirling vortices that can set up resonant vibrations. In extreme cases, this can cause catastrophic structural failure. The Tianjin Tower's curves disrupt this pattern. The aerodynamic shape prevents vortices from forming consistently, dramatically reducing wind forces on the structure. The building also features strategically placed multi-story wind vents and a porous crown that lets air pass through rather than building up pressure. By optimizing the structural design, SOM's integrated architecture and engineering team dramatically reduced the steel required for construction. These material savings had multiple benefits. Less steel meant less weight, which reduced seismic forces on the foundation. It eliminated the need for a separate dampening system, a massive pendulum or liquid-filled tank that many supertalls require to prevent swaying. The reduced construction time and cost made the project economically viable despite its extreme height. The construction timeline hit key milestones rapidly. In July 2016, the concrete core reached 260 meters. In April 2017, the structure topped out. On October 31, 2017, workers installed the distinctive steel crown atop the building, completing the upper envelope and reaching the full 530-meter height. The building used building information modeling extensively, one of the early supertall projects to integrate BIM with IoT sensors and RFID tags throughout construction. This technology allowed real-time tracking of construction elements and automatically alerted teams to potential conflicts between structural, mechanical, and electrical systems. The approach reduced rework and improved efficiency in a project with thousands of components being assembled simultaneously. The foundation required deep piles driven 97.5 meters into the ground, with an effective pile length of 71.2 meters. Each pile can handle a vertical compressive load of 12,700 kilonewtons, roughly equivalent to the weight of 1,300 cars stacked on a single point. The building cost approximately $1.2 billion to construct. Efficient for a structure of this scale and complexity, much of that efficiency came from the optimized structural system that reduced material use while maintaining safety margins well above code requirements. While the new Tianjin district was one of China's first state-level economic zones, it lacked a defining landmark. The CTF Tower provided that identity, visible for kilometers across the flat coastal plain. The Tianjin CTF Finance Center and the one in Guangzhou prove that two buildings at exactly the same height can tell completely different stories. One uses terracotta to connect with local tradition. The other uses curves to battle physics. Both reach 530 meters, but they got there by solving different problems in different places for different purposes. That's the real achievement. Not the height itself, but the intelligence behind it. In the heart of Beijing, a new giant reshaped the skyline and challenged everything the city thought was possible. Standing at approximately 530 meters, China Zun, also known as the CITIC Tower, is the tallest building in the capital. But more than its height, what makes this tower extraordinary is the story behind how it was built, a tale of ambition, engineering ingenuity, and the delicate balancing act of constructing a super-tall skyscraper in one of the world's most politically and culturally sensitive cities. The story begins in 2011, when Beijing was cautiously opening its doors to super-tall development. Height restrictions had long dominated city planning, a safeguard against both aesthetic disruption and seismic vulnerability. The approval process alone required negotiation at the highest levels of municipal government. Planners wanted a statement, a building that would declare Beijing's economic power, but one that would also respect the city's traditions. The resulting compromise gave birth to the unusual form of China Zun, a shape inspired by an ancient Chinese wine vessel, wide at the base, narrow in the middle, and expanding again near the top. Elegant to the eye, this design was a nightmare to build. Early construction began with a focus on the foundation, a critical challenge in Beijing's clay-heavy soil. Engineers poured thousands of tons of high-strength concrete, extending deep into the bedrock. The foundation itself was a feat of precision. Any miscalculation at this stage could compromise the entire tower. Workers labored under strict quality controls, monitoring every pore, every beam, and every anchor. This painstaking preparation delayed the start of vertical construction, but ensured that the superstructure would rise safely above the city streets. Once construction above ground began, the real drama unfolded. China Zun's unusual shape presented structural challenges that demanded advanced solutions. To resist strong winds and earthquakes, engineers designed a megaframe system combined with outrigger trusses, connecting the reinforced concrete core to the perimeter columns. In simple terms, imagine a giant spine linked to ribs, allowing the building to sway slightly in extreme conditions without breaking. Invisible from the street, but essential for safety, especially given the tower's height, which subjects it to wind speeds far higher than those at ground level. Adding to the complexity, China Zun incorporated cutting-edge construction technology. Vertical cranes had to operate near their maximum capacity, lifting steel beams and prefabricated floor sections hundreds of meters into the air. Logistics planning became a science. Materials were sequenced with military precision, just-in-time delivery was critical, and scheduling accounted for wind, rain, and the seismic sensitivity of the soil. Every day, engineers calculated how the building would move, how much it would twist under wind pressure, and how stresses would transfer from the exterior to the core. For a building of this scale, minor errors could become catastrophic. As the tower rose, the pace slowed, not from incompetence, but from deliberate caution. At over 500 meters, even a small deviation could jeopardize safety. Floor after floor, workers monitored vertical alignment, load distribution, and material integrity. Concrete had to cure precisely. Cranes had to operate at optimal wind conditions, and every beam placement was double-checked. This was not a race. It was a methodical ascent into the clouds. The tower finally topped out in 2018, 7 years after construction began. But topping out is only the beginning for a building of this magnitude. Interior fit-out, mechanical systems, elevators, safety certifications, and tenant installations took another year. China Zun officially opened around 2019, marking nearly a decade of continuous planning, design, and construction, a timeline that reflects both the ambition and caution required to deliver such a skyscraper in Beijing. The sheer scale of the building is staggering. With 108 floors, each level is home to offices, observation areas, and mechanical equipment. From the ground, it can feel almost impossible to take in. For comparison, the tower is taller than the Empire State Building, yet with a slimmer, more elegant profile. The widening at the base and top creates the illusion of stability while adding usable space, a perfect marriage of aesthetics and functionality. China Zun was also a massive financial undertaking. Estimated costs ran into the several billion-dollar range, a figure that reflects not just the structure itself, but also the planning, technology, and risk management embedded in every phase. From the city's perspective, this investment was about more than office space. It was a declaration: Beijing could host super-tall buildings with the same technological sophistication as Shanghai, Shenzhen, or Hong Kong. Today, China Zun is more than a skyscraper. It is a symbol of national ambition. Its reflective glass catches the sunrise over Beijing. Its curved silhouette dominates the skyline, and its interior hums with the operations of multinational corporations. And yet, much of its impact is invisible. In the careful engineering decisions, the precise concrete pours, the mega-frame spine that allows it to dance with the wind, and the relentless coordination of workers, engineers, and architects over nearly a decade, China Zun is a narrative written not just in steel and concrete, but in every decision that allowed the tallest building in Beijing to rise safely, elegantly, and permanently into the sky. In the heart of Shanghai's bustling Pudong district, a towering trapezoid rises above the city like a vertical gateway to the future. The Shanghai World Financial Center, standing at nearly 500 meters, is not just a skyscraper. It is a statement of China's economic ambition and engineering daring. From the very first design sketches to the moment it topped out, this building's journey tells a story of patience, innovation, and overcoming seemingly impossible challenges. The idea for the tower was conceived in the late 1990s, at a time when Shanghai was transforming from a regional port city into a global financial hub. The government envisioned a vertical symbol that could represent the city's modern identity, a tower that would rival the world's tallest structures while fitting within the soft, reclaimed soils of the Huangpu River Delta. The initial concept was bold, a supertall with a circular opening at the top, designed to lighten the visual mass and reduce wind stress. However, cultural and technical considerations soon altered the design. By the early 2000s, the opening had been reimagined as a trapezoid, giving the building its distinctive bottle opener silhouette, a shape that is instantly recognizable across the skyline and a marvel of structural engineering. Construction officially began in 1997. Progress was immediately interrupted by the Asian financial crisis. Funding stalled, and for several years, the site lay partially excavated, a reminder of the economic uncertainty sweeping the region. Work resumed in 2003, but restarting the project was no simple task. Engineers had to reassess the design to meet updated safety standards, seismic codes, and new wind load calculations. Foundation, already partially in place, had to be carefully integrated with revised engineering plans to ensure that the tower could bear its colossal weight without settling unevenly in the soft delta soil. Building on Shanghai's soft, waterlogged ground presented one of the greatest challenges. To anchor the structure, engineers drove over 1,000 reinforced concrete piles deep into the bedrock, creating a foundation that could support the enormous mass of the skyscraper above. The tower's weight is astonishing. Nearly 1 million tons of concrete and steel hold up this vertical city. But it was not just about size, it was about balance. The engineers designed a central reinforced concrete core, surrounded by a perimeter mega-frame of steel. This combination allowed the structure to resist wind forces that can reach hurricane speeds at the upper floors while minimizing sway that could unsettle occupants. As the tower climbed, the construction story became one of precision and patience. At nearly 500 meters, wind loads increased dramatically, and every beam, floor slab, and elevator shaft had to be installed with meticulous care. Cranes lifted prefabricated components hundreds of meters above the ground, operating near their mechanical limits. Concrete for upper floors had to be pumped under extreme pressure, and workers contended with temperature fluctuations, humidity, and the risk of wind gusts strong enough to halt operations. Unlike smaller buildings, speed was never the main goal. Safety and alignment took precedence, and progress was often measured in meters per week rather than floors. By 2007, the Shanghai World Financial Center had begun to dominate the skyline. Its trapezoid opening, 100 meters across, created a dramatic visual contrast with the surrounding towers and reduced wind vortex effects that could otherwise twist the structure. But the project still faced delays. The elevator systems alone required complex engineering, double-deck elevators capable of reaching the observation decks in less than a minute, with emergency systems designed to function in high winds and seismic events. Installing these systems took months of careful calibration and testing. Finally, the building topped out in 2008, over a decade after the initial groundbreaking. Fit-out and mechanical systems were completed the following year, and the tower officially opened in 2008. The cost was substantial, exceeding $1 billion, reflecting not just materials and labor, but also the sophisticated technology, deep foundation, and high-precision equipment required to bring it to life. What makes the Shanghai World Financial Center truly remarkable is not just its height, but the way it redefined the possibilities of urban construction. With 101 floors above ground and 3 below, the tower houses offices, hotels, observation decks, and mechanical floors in a vertical city that stretches nearly half a kilometer into the sky. For perspective, the building is taller than the Empire State Building, yet it feels lighter, more elegant thanks to the tapering form and the trapezoid aperture. Visitors stepping onto the observation deck experience a view that seems to float above the clouds, a dramatic testament to human engineering and ambition. The tower's story is also about resilience and adaptability. From design revisions caused by cultural considerations to the pauses enforced by economic crises, each challenge required innovative solutions. Every aspect of the project, from the mega-frame structural system to the high-speed elevator installation, demonstrates a careful blend of ambition, technology, and problem-solving. China's engineers and planners proved they could build at a scale and speed unmatched in many Western cities, yet with a precision and sophistication that ensured safety and longevity. Today, the Shanghai World Financial Center is a landmark, not only for Shanghai, but for the world. It represents a period in China when the country was asserting itself on the global stage, using engineering and architecture as symbols of economic power. Every floor, every window, and every structural element tells a story of a city determined to rise, literally and metaphorically, above the challenges of finance, soil, wind, and time. In Hong Kong, land is a luxury, and the sky is the only frontier left. Rising to approximately 480 meters, the International Commerce Center, or ICC, is the tallest building in the city, and a striking example of what happens when ambition meets constrained space. But its story is far more than just numbers and glass facades. It is a tale of meticulous engineering, daring logistics, and construction ingenuity in one of the most densely populated cities in the world. The ICC project began in the mid-2000s as part of the massive Union Square development atop Kowloon Station. Unlike most skyscrapers that start on empty lots, ICC was built directly over a busy transit hub. Trains, tunnels, and a web of utilities ran beneath the site. Every foundation pour, every steel column had to account for this complex underground network. It was a puzzle that could not tolerate mistakes. Early site preparation took months longer than anticipated, as engineers excavated and reinforced the subterranean infrastructure while ensuring that daily train operations above ground were not disrupted. The design challenge was immense. Hong Kong's territory is mostly reclaimed land, with soft soil that can settle unevenly under extreme weight. For a tower of nearly half a kilometer, this was a major concern. To address it, engineers employed over 1,600 high-capacity reinforced concrete piles, each driven deep into the bedrock. The foundation alone required precision surveying and constant monitoring for settlement, because even a few centimeters of uneven movement could create catastrophic stress at higher floors. The foundation phase extended through 2007, marking the first significant milestone in what would become a decade-long journey. Once the base was completed, vertical construction began in earnest. The ICC's structural system is a hybrid, combining a central concrete core with perimeter steel columns that taper subtly toward the top. This combination gave the building both strength and flexibility, essential for resisting the strong typhoon winds that sweep Hong Kong each year. The tapering form wasn't just aesthetic, it helped reduce vortex shedding, a phenomenon where wind can cause a tall structure to twist or sway dangerously. Climbing nearly 100 floors above ground, the ICC's construction was a feat of vertical logistics. Cranes had to lift prefabricated components hundreds of meters, often stopping during high winds or heavy rain. Materials were delivered in a precise sequence to prevent congestion and delays. Every floor added complexity because the elevators, mechanical systems, and hotel and office spaces all had to be installed simultaneously in a vertical timeline. Construction crews worked around the clock, often in shifts of 12 hours or more, to keep pace with the ambitious schedule. Despite careful planning, the project faced several delays, excavation issues, typhoons, and the challenge of integrating the tower with surrounding infrastructure caused setbacks. In particular, the complexity of building over a live transit hub added weeks of careful coordination for every step. But these obstacles didn't slow the determination behind the project. By 2010, the ICC had reached its full height, a towering presence visible from across Victoria Harbour, dominating the Kowloon skyline and creating a new benchmark for urban supertall construction. The ICC is not just a giant tower, it is a vertical city. It accommodates offices, a luxury hotel, observation decks, and mechanical floors, all stacked into one building. The observation deck, near the top, offers views that extend across Hong Kong and the South China Sea. From the harbor, the tower seems impossibly tall, nearly touching the clouds, a visual anchor for the city that is as much engineering marvel as aesthetic statement. For context, the ICC is taller than the iconic Empire State Building, yet it occupies far less horizontal space, a demonstration of vertical efficiency in one of the world's most densely populated urban areas. Financially, the tower was a massive undertaking. Costs ran into the billions of US dollars, covering not only the materials and labor, but also the intricate engineering solutions required for its foundation and structure. It is one of the most expensive skyscrapers ever built in Hong Kong. Yet, the investment reflects more than construction. It symbolizes the city's determination to innovate and grow vertically despite geographic constraints. What makes ICC particularly remarkable is how it embodies China's, and specifically Hong Kong's, approach to skyscrapers, combining speed, precision, and audacity. Unlike earlier towers that unfolded slowly over decades, ICC's construction employed cutting-edge prefabrication, computer-aided simulations, and wind tunnel testing at every stage. Engineers could model how the building would sway in typhoons, how elevators would operate under full load, and even how temperatures at different heights would affect structural expansion. Every decision, from the type of steel used to the thickness of the glass panels, was calculated to balance safety, efficiency, and elegance. Today, ICC is more than a building. It is a marker of urban ingenuity. From the streets of Kowloon, it appears to rise effortlessly, but anyone who understands skyscraper engineering knows the story beneath. A decade of planning, an army of engineers and workers, a foundation hundreds of meters deep, and technology that lets a vertical city stand safely atop soft soil and a busy transit hub. It is a triumph of human design, a vertical expression of ambition in a city where horizontal space is a rare commodity. In the skyline of Hong Kong, the ICC stands as both icon and inspiration. In a region where land is scarce and the skies are busy, it demonstrates that the future belongs to those who can master both the ground below and the air above, just like the next tower on our list. Changsha is not a coastal megacity. It is not a global financial hub. And that is exactly why this tower matters. At around 450 meters, Changsha 1FS Tower T1 rose rapidly in the 2000s and 10s, surprising many observers. Construction began around 2013, during a period when China's interior cities were accelerating their development. The pace was relentless. Floor after floor climbed in quick succession, high-strength concrete, prefabricated components, and around-the-clock construction schedules made speed possible. Engineering focused on efficiency. The tower uses a reinforced concrete core with perimeter columns designed for both gravity and lateral loads. Simple, robust, scalable. By 2017, the tower was complete. In just a few years, Changsha had gained a skyline landmark that rivaled coastal giants. The cost ran into the hundreds of millions, but the real story is speed. This building showed how China could replicate supertall construction far beyond its traditional centers. In the rapidly modernizing city of Changsha, far from the coastal hubs of Shanghai or Hong Kong, a new kind of skyline ambition took shape, rising to approximately 450 meters. The Changsha IFS Tower, T1, is the tallest building in Hunan Province, a vertical statement of technological mastery and urban transformation. Yet its story is less about glamour and more about the sheer audacity of building a supertall in a city not traditionally known for skyscrapers, demonstrating China's ability to spread its engineering prowess inland. Construction began around 2013, during a period when Chinese cities far from the eastern coast were embracing rapid urbanization. Changsha's leaders wanted a symbol of modernity, a tower that would redefine the city's skyline, attract investment, and signal that the city could compete with its more famous counterparts. The challenge was monumental: build a 450-meter supertall on a site that was already dense, with limited space for staging materials, cranes, and construction logistics. The first step was the foundation. Changsha's soil is a mix of clay and bedrock, which required extensive soil stabilization. Engineers installed hundreds of deep piles, reinforced with steel and high-strength concrete to anchor the tower safely into the ground. Advanced monitoring systems tracked settlement constantly, ensuring that even minor shifts were corrected immediately. Unlike more forgiving sites in coastal cities, here every centimeter mattered because there was little room for error. Once the foundation was complete, vertical construction began with astonishing speed. The tower rose floor by floor, leveraging prefabricated floor slabs and modular construction techniques to accelerate the schedule. The combination of concrete core and perimeter steel columns allowed each floor to be erected quickly without sacrificing stability. Workers often operated in shifts around the clock, keeping the project moving at a pace that was remarkable for a city just beginning to develop supertall construction expertise. The design itself was a bold statement of modern engineering. The building tapers slightly as it rises, reducing wind load and ensuring stability. Engineers used outrigger trusses connecting the core to the perimeter columns, allowing the tower to flex safely in strong winds. The upper floors are equipped with dampers to absorb sway, a subtle but essential feature that keeps occupants comfortable while minimizing stress on the structure. The building is a technical marvel, yet the engineering is seamless, invisible to the casual observer who sees only a sleek vertical form dominating the Changsha skyline. Despite careful planning, the project encountered challenges. The rapid pace of construction sometimes conflicted with supply logistics. High-strength concrete had to be delivered on schedule and poured quickly, or floors could not be completed in time. Equipment failures, weather delays, and the occasional typhoon threatened to slow progress. But the construction team adapted, using prefabrication and precision scheduling to maintain momentum. By 2017, just 4 years after breaking ground, Changsha 1FS Tower T1 had topped out, a testament to both efficiency and determination. The interior fit-out took another year, incorporating offices, retail spaces, and luxury apartments. At the very top, observation decks and mechanical floors required meticulous attention because the stresses at the uppermost levels are far higher than at the base. Elevator systems, designed to move thousands of people efficiently, had to be calibrated for speed, weight, and safety. Even the glass curtain wall, which appears uniform and smooth, was engineered to resist wind pressures and thermal expansion across the building's height. From the ground, the tower's scale is almost dizzying. Standing next to older mid-rise buildings, it seems impossibly tall, stretching into the clouds. At 450 meters, it is taller than New York's Empire State Building, yet its footprint is comparatively modest, giving it a sense of vertical elegance. The tapering form, combined with reflective glass, creates the impression that the building is both light and strong, a visual illusion crafted through engineering precision. Financially, Changsha IFS Tower T1 represents a major investment in the city's future. Costs were estimated in the hundreds of millions of dollars, including foundation stabilization, high-strength materials, prefabrication technology, and specialized elevator systems. For a city of Changsha's size, this was a transformative commitment, signaling that urban growth and modern architecture were not limited to coastal megacities. Beyond the numbers, the tower has had a profound symbolic impact. It demonstrates that the super-tall skyscraper era in China is not confined to Shanghai, Beijing, or Shenzhen. Cities inland can now dream big, relying on advanced engineering, rapid construction techniques, and innovative logistics to realize projects that might have been unimaginable a decade earlier. The tower serves as both a literal and figurative beacon, reshaping the skyline while inspiring future development throughout the region. Changsha YFS Tower T1 also exemplifies China's methodical approach to skyscraper construction. Plan meticulously, innovate constantly, and build with speed and precision. From its deep foundation to its high-tech elevator systems, from wind-resistant design to prefabricated floors, every element was orchestrated to overcome both geographic and technical challenges. The result is a building that feels effortless in its majesty, yet every meter is the product of painstaking work and sophisticated engineering. Today, the tower dominates the Changsha skyline, visible for miles in every direction. For engineers, it is a case study in high-rise construction in emerging urban centers. Standing at approximately 450 meters, the Zifeng Tower, also known as the Greenland Center, is the tallest building in Nanjing and one of the earliest inland supertalls in China. Construction began in the mid-2000s, when Nanjing was pushing to modernize its skyline while preserving its historical identity. The challenge was building high without overwhelming the city. The city's leaders envisioned a tower that would not only reshape the skyline, but also serve as a symbol of economic confidence. Unlike coastal megacities with decades of skyscraper experience, Nanjing presented unique challenges. The soil was a mix of clay and soft sediment. The urban fabric was dense, and the construction team needed to integrate modern systems in a city with historic constraints. The foundation work alone was a monumental undertaking. Engineers drove hundreds of deep piles into the ground, anchoring them into solid strata below the soft surface soil. Continuous monitoring systems measured settlement to fractions of a centimeter, ensuring that as the tower rose, it remained perfectly vertical. Any miscalculation could have led to catastrophic structural problems. The foundation phase stretched over more than a year, a slow and meticulous prelude to the tower's ascent. Vertical construction began with a focus on precision and speed. The Zifeng Tower's core is reinforced concrete, a choice that provides both stiffness and strength. Surrounding this core are perimeter columns that gradually taper toward the top, giving the tower both stability against wind and elegance in its form. Engineers incorporated outrigger trusses and belt trusses, distributing wind and seismic forces efficiently through the structure. For a building of this height, these measures were essential. Without them, the upper floors would sway dangerously during typhoons or minor earthquakes, which are not uncommon in Jiangsu province. The construction team relied heavily on prefabricated components and innovative construction sequencing to maintain speed. Floors were often pre-assembled off-site and lifted into position, reducing the time workers needed at extreme heights. Cranes operated near their maximum capacity, lifting steel beams and reinforced concrete sections hundreds of meters above the street. Every day, engineers monitored the structural alignment, adjusting tension in the trusses and verifying verticality to ensure the tower remained within millimeters of design specifications. At times, construction paused temporarily to recalibrate, a necessary step to prevent cumulative errors as the building rose higher into the skyline. By 2009, just 4 years after breaking ground, the tower had topped out, yet topping out is only the beginning. Interior systems, including high-speed elevators capable of whisking passengers to the top in under a minute, Mechanical floors and luxury office fit-outs required meticulous attention. Curtain walls were installed with precision, designed to resist wind pressures, reduce thermal expansion, and provide uninterrupted panoramic views of Nanjing and the Yangtze River. Engineers even accounted for microclimatic effects, such as temperature differentials at high altitude, which could affect both structure and glass integrity. The scale of the tower is breathtaking. With 89 floors above ground and 3 below, Zifeng Tower houses offices, retail spaces, and luxury hotel accommodations. From street level, the building appears impossibly tall, dwarfing surrounding mid-rise developments. Standing next to older Nanjing structures, it is easy to forget the years of planning, calculation, and coordination that allowed it to reach nearly half a kilometer into the sky. For context, it is taller than most historic landmarks in the city and exceeds the height of the Eiffel Tower, yet occupies far less ground area, a masterclass in vertical efficiency. Financially, Zifeng Tower represented a massive investment in the city's future. Total costs ran into the hundreds of millions of dollars, covering deep foundation work, high-strength materials, prefabrication technology, and complex elevator and mechanical systems. For Nanjing, the investment was transformative, signaling that the city was capable of executing projects at the same technological and financial scale as the coastal megacities. The tower's impact extends beyond its physical presence. It reshaped the skyline, altered real estate values, and set a precedent for super-tall development in inland cities. It demonstrated that sophisticated engineering, high-speed construction techniques, and advanced logistics could be applied outside of traditional skyscraper hubs. Zifeng Tower became a model for other inland projects, proving that height, speed, and modernity were not limited to Shanghai, Beijing, or Shenzhen. Today, Zifeng Tower dominates Nanjing's skyline. Its reflective glass catches the sunlight across the Yangtze River. Its tapered silhouette balances visual grace with structural necessity, and its sheer presence signals economic vitality. Visitors can ride high-speed elevators to observation decks that offer uninterrupted views stretching across the city, glimpsing the full scale of urban growth below. Zifeng Tower proved that China's skyscraper boom was not limited to a few cities. It was national, systematic, and only getting started. These tall skyscrapers are a testament to what happens when vision, engineering, and determination converge to create something that touches the sky and redefines the cities below. But what do you think of these super tall and megatall buildings? Let us know in the comments. And make sure to follow Signum for more fascinating stories of the most impressive mega projects from around the world.